Welcome everybody to this webinar on building bridges between IT and data science. We're excited to have you here today. We have a great webinar in store for you. I'm Josh Podeska. I'm the Chief Data Scientist at Domino Data Lab, and we are pleased to be hosting this webinar and leading it today. To set this stage for what we're going to talk about, we have a great opportunity in front of us as IT and analytical professionals, as an industry. There's a lot of momentum right now with machine learning and with artificial intelligence. And we have an opportunity to do something very special, to build products, to build solutions that are going to make a real difference in the world in our various disciplines and various fields of application. But we also have a lot of challenges ahead of us right now, a lot of obstacles to overcome. And not the least of which is learning how to work together with IT and analytics, being able to build that bridge. So I almost think of today as relationship counseling. So we're going to be going through that today. We have a lot of great speakers that will be joining us and participating in the panel. I mentioned myself, and we'll go through each individual here and get an introduction, just a brief introduction on me. I've been in the analytics space for 20 years, focused primarily in public sector and manufacturing. And I've also led up a few analytical programs at various software companies. So that's me, and we will go through and do introductions here.
Thanks, Joshua. Hi, everyone. My name is Ben Diaz. I'm, as Josh said, the data science and analytics director at EasyJet. I've also worked previously at Unilever, Tesco, and Royal Mail, all in data science, in the data science space. So got a lot of experience working across IT and data science as well, and feeling the pain points as well. So this is a really good topic, and I'm excited to be here. Peter, do you want to go next?
So my name is Peter. I'm currently a data scientist at Janssen, which is an arm of Johnson & Johnson, handles all the pharmaceuticals, and I'm in the research and development area. My previous lives have been product managers for a lot of SaaS companies, and been in healthcare space for the past 8 years or so.
Hello, everyone. My name is Cesar Goulart. I'm the CIO at PointRight. I've been with the company for 4 years. We're a predictive analytics company that offers a SaaS platform to skilled nursing facilities and other stakeholders in the post-acute segment of healthcare. Prior to joining PointRight, I was CTO of a large health system, and then prior to that, CIO of a health plan. So I've been dealing with trying to embed analytics in some capacity and at some level with business and with products, probably for close to 20 years, I think.
Kjell Carlsson, Principal Analyst at Forrester, where I cover data science, machine learning, and various technologies in the artificial intelligence space, like computer vision and speech analytics. And so it's wonderful in that I often get to speak with folks about the incredible things that they do. But Josh, similar to you, I often feel like a therapist for data science teams and data engineering teams, hearing about the extraordinary challenges that they go through in order to extract the incredible opportunity that there is, which we all recognize, but which, again, is so difficult and often more resembles trench warfare or couples counseling as it does actual data science.
Yeah, wonderful. Thank you each for your introductions. And Kjell, can you take it away?
Absolutely. I think that there are three really big things that we would love, that we really need to get the panel's view on, that we need to address in order to be able to go after this. Well, first of it is, well, why are we doing this? I know probably everybody who's attending this session today is already somewhat convinced over the opportunity and just how important this is, but we should go into it and delve it into more depth and just talk about, well, so what's real? Why is this so important for your individual organizations? Also, then but so why is it so difficult? What are the causes? What are the pitfalls that we should be on the lookout for when it comes to extracting this opportunity? But then also we want to take advantage of the panel's knowledge and the best practices that you've seen in terms of, well, how do we bridge that divide? How do we leverage the different, whether on the people side, the process side, or the technology side, the opportunities, the avenues that we have in order to be able to cross the aisle, bridge the gap? And as Josh said, please do ask questions as we go along. And if we don't get to them, we'll try and get them to them at the Q&A session afterwards. But so given that we are all talking about data-driven decision making, I thought we'd kick it off with some data. Specifically, in the surveys that we here at Forrester do on an annual basis, yes, we've been seeing in the order of 75 to 80% of the organizations that we survey say that, well, we're either some of us are implementing, upgrading, have implemented various AI, ML, and deep learning solutions. But we've consistently in prior years seen about a third of firms every year tell us that, we're planning to, another 12 months, another 12 months. So this year, in addition to the fact that these are the highest numbers that we've ever seen, 86% of firms telling us that they are either planning to or leveraging this, what's really noticeable has been the increase in the number of firms that says, well, we're not just planning to, we're already doing this. That jump from the 54% in 2019 to the close to 70% in 2020 is the largest increase by an order of magnitude that we've seen from year to year. Usually budgets like 1 or 2%, a 15% increase. Folks are convinced and have already started. I also see this in other surveys that I've done. I did one where I was able to segment out high growth firms versus low growth firms and ask them about, so what are you seeing? How important this is for you? In one of the recent ones of those, I found that 71% of those, of that 50% of firms that were growing the fastest out of that sample said that not just that AI would be an important factor determining competitiveness, but said that it was the single most important factor determining their competitiveness in the future, in the next 3 years. And 40% of them, close to 40%, were saying that, well, it already was the single biggest factor determining their competitiveness. And in our surveys, we've finally started asking folks, so, what impact has this actually seen? And I promise that next year I will insist that we don't just ask about negative, neutral, and positive, but at least work in extremely positive or other qualifiers there. But 3/4 of the firms that we're serving, of the ones who've said that they've already implemented, are already seeing a positive impact. In other surveys, when I'm asking folks about how much they're investing, 60% say that it's either larger or largest investment area. And when you look at those higher growth firms, 1 in 5 are saying that, it's already their single largest investment opportunity. I do get the privilege of going and talking to folks on a daily basis about the whole range of different use cases that they're deploying or planning to deploy. And they range from the mundane intelligent document extraction, mundane but very valuable, all the way to the quite literally out of this world. I was speaking with a company that is looking to deploy deep learning models on satellites to reduce the amount of data that they have to beam back to Earth. But I think it would be wonderful here to ask the panel, I mean, why is this important for you? What are things that you're tackling, and where have you seen it have the most impact so far? I don't want to call people out, but please feel free to jump in as you see fit.
I'll start. I think for us, as I mentioned, I'm with a predictive analytics company that's been in business for 20 years. And as you can imagine, anyone that's been in business for 20 years is dealing with some legacy stuff. In our case, it was a legacy technology stack that was being used by the analytics research team that was all done in SAS. And then we had a very inefficient process for translating every piece of code that came out of our data science team from SAS to C#, which is where everything else is written, and everything got dropped to paper. So when you start talking about the comments that you get from data scientists about how long it took to do it and how long it took to deploy it, that's at the root of a lot of this stuff, right? So that our biggest opportunity is to really better connect the life cycle of the data science team with our product life cycle, eliminate code translation, and speed up time to market of new capabilities that are driven by research. I mean, that's the clear opportunity for Point Right when it comes to it. And
I guess when thinking about that use case, I imagine a big chunk of this is just the types of methods that it enables data scientists to use. Absolutely. I mean, often a deployment pipeline like that, it gets really difficult to use any things that go beyond logistic regression models or piecewise linear models and things along those lines. Yes, I'm imagining that a key value proposition here was, well, we can make those models a lot more accurate, and we can leverage a lot more data in it. Or could you help us understand that part?
And we're seeing this across the board when we go from your basic logistic regression models to using some boosted regression methodologies and some even shallow neural networks. You see performance jumping pretty spectacularly. You're seeing like C statistics jumping from the 0.6 range to the 0.8, 0.9 range when you go from one to the next one.
Very nice. I guess I'm curious, in the context of COVID, naturally the skilled nursing facilities that you're doing predictive analytics for are kind of in the eye of the storm, or what is the right term of where in the midst of a perfect storm. I guess I'm curious about the speed of iteration, because I imagine a lot of the models that you have need to be updated very rapidly. And I guess I'm curious, does it also help on the experimentation side, or even just on the keeping those models up to date side of things?
We actually see it all over the place. There are certain models that don't change that much over time. So when you refit those models, they're basically the same. You may change some coefficients, but that's about it. And there are some models that change pretty dramatically when we refit them. So we have a schedule for looking at these things. Some of it is defined by the National Quality Forum, which endorses a couple of our models. So we have to do some things on a given schedule to keep the endorsement from the NQF. But other stuff, it's based on our knowledge. So for example, our mortality model, it doesn't change that much. The things that end up triggering mortality in 6 months at a skilled nursing facility over time tend to not change that much. But when it comes to COVID and what's happened with COVID, because of the fatalities that we have seen, is the attention that's being paid to this space by a bunch of other industries that are now trying to pay attention to what's coming out of skilled nursing facilities and the level of care that's provided in those places to try to reduce the number of fatalities.
No, indeed. Peter, I was curious. I mean, you're doing what so many data scientists I know of want to do, which is leveraging deep learning for an area of the pharmaceutical realm. I'm curious on your side, what you're seeing here and what have been the biggest opportunities for you?
Yeah, so I think the data science meeting healthcare is something that's a little bit new in terms of the whole machine learning space. I guess traditionally statistical machine learning did start out in the biology space, but right now we're looking at more advanced methods like deep learning. And I think, what we're doing in computer vision space is just one aspect of what is going on broadly at Janssen. So we're applying machine learning, computer vision to images. Okay, so we have computer vision, applied to images that are being generated in a lot of our clinical trials, but we're also looking at the marriage of other data modalities with other types of machine learning, right? So if we look at NLP, for example, there's really good use cases for NLP and things that are in unstructured text that are being generated out of EHR systems and clinical systems that we can pull insights out of. And then there's things that just like plain machine learning, we're applying, basic models like your survival models, your propensity score matching, et cetera, to just generating, the things that you need in a biostatistics sort of sense. I consider all those as data science, right? Even though they're classically considered as statistics or biostatistics, but I think we're really broadening scope of what data science is, and healthcare at heart, I think, is a very data-driven industry. So, tons of opportunities in the space, and a lot of methods and data we have not explored yet.
Indeed. Well, if only we could get more. We get outcomes metrics from the clinical trials research. If only we could get more outcomes metrics from the clinicians, then we'd be able to do so much more. Ben, how about on your side?
Yeah, definitely. So COVID has certainly changed stuff, and transformed the way we're using data and having to use data. And I think that the questions being asked are different because as a result. And so what we're finding is, having thought about it, I think there are like high-level 4 areas that we're using more machine learning data science approach. And one is kind of introducing more automation because we have more to do with the same number of people. So doing more with less, because previously we'd had 2 schedules a year, one winter, one summer, and that was it. Now we're having to change the schedule almost every month, every week, and so that's more work, but the same amount of people. So automation is a key there. And when you automate stuff, you can also include optimization, which makes it a bit better as well, which is great. Then kind of going back to what Cesar was saying, EasyJet was just celebrated 25 years, and so there's some legacy there. And there were some rule-based algorithms that were doing well when people were following the rules, but COVID has changed that. So customers and competitors are not following the standard rules that you could code into standards. So we're having to move to more of a predictive analytics, forecast-driven approach rather than a rule-based approach in some areas. Incorporating external data sets has been a big theme, where previously you could rely on your internal data because what happened last year is more or less what's going to happen this year with a bit of change. But now it's changing all the time, and it's changing based on external factors. So you need that external data to give you that external knowledge and that signal of what's changing and how to react. So there's a lot of work going on in how do we incorporate these more dynamic and external signals to create more dynamic changes in the models. And finally, we're actually having to do it a lot quicker than I expected, moving from machine learning to AI. Machine learning for me is where you teach the machine, say, give it some data sets, historical data sets, and say, this is what it looks like, and go do it in the future. Now, the historical data sets are not indicative of what's happening in the future because everything's changing. So when we have big change points like a pandemic hitting, you need more AI reinforcement learning algorithms that will learn from the new data that's coming through. And so we're having to go into that space a lot quicker than I expected because of this situation. So they're kind of like the 4 high-level areas where we're applying data science at the moment.
Thank you. I would love to say that we had thought through, as we were setting up this webinar, that we wanted folks who are representing both the innovation side of things, which would be you and Peter, the productization of machine learning, which I guess would be you, Cesar, and all of the operational efficiency side of things, which would be you, Ben. And I would love to say that we also thought through that we wanted the organizations who were most in the news right now because they were tackling with the most relevant things, whether that be organizations which are struggling to adapt to COVID on the airline side, or organizations which are looking to develop new medicines or new vaccines against COVID, which I guess would be you and Peter on that side, and organizations which are helping to adapt healthcare or to make healthcare more data driven, which would be you, Cesar. I would love to say that we had that as a master plan going into this, that we were selected you because of those, and so of course we did that. Yes.
That's what Josh told me last week that you guys had designed.
Indeed, it was very carefully thought through, and it wasn't just because we thought you guys were the best representatives of these problems and had the most experience, in the trenches of tackling these. It was that, well, and it was that too, of course. But let's move to that section of, well, just so why is this so hard? And it's one of those areas where we would expect there to be a lot of alignment, where we would hope that folks would be viewing themselves as being part of the same team and working towards this common goal. We're all data-loving professionals. We all know that there is this opportunity leveraging that data with machine learning methods and going in and building better software around it. So, we could be like these folks who are just happened to be soldiers in no man's land during 1914. Getting to yes, occasionally that happens. Occasionally the stars align, but so frequently the reality in most organizations is more like this. You have different teams with fairly entrenched positions, with different incentives, who often by working with each other are working against their own interests. I often joke that it takes a village to grow a successful, whether it be data science, machine learning, or AI project, and really it's not just 2 groups here. It's not just the data engineers and the data scientists, or IT versus the business. It's sort of a tripartite relationship. So I guess I don't watch The Crown, but I guess if you were thinking The Crown, this would be Prince Charles, Camilla, and Diana. But on a more serious note, usually it requires a driving alignment and engagement by all of these parties doing what it is that they can do better than anyone else. And that tends to be a struggle. It never happens organically, and there are almost always trade-offs for how you tackle it. I mean, my favorite quote in this space, John Huffman used to be the chief scientific officer for data science and AI over at Philips. Now it's at a startup, and he had this great line. One of the interviews I did with him about the problem with analytics and AI has nothing to do with analytics and AI. And that's not to say that it's easy, but the challenges of getting the data that you need, working with the data engineering team in order to build that pipeline, getting the infrastructure that you need, training that model, making sure you're training that model against the right goal, that it's useful for the enterprise, but then deploying that model and getting it into software in a form that is then usable by the end users. That's a giant problem, which goes far beyond the already difficult challenge of model development. And so I'm reminded of interviews that I've had. One of them was with a data science team at one of the big public cloud providers, who was talking about how, if he was a customer of his company, he would be able to get access to all of this infrastructure that he couldn't as an internal team. It would be easier for him effectively to buy the infrastructure he needed from a competitor cloud. I'm reminded of a health payer where they were talking about the toxic culture that had emerged between their data scientists and their analytics professionals and their data engineers, where you ended up with this A team versus B team. And anything that you did that was working with the other group was working with the enemy. And not to mention any number of conversations I have where folks are talking about just how getting access to the tools and infrastructure that they need can take weeks, sometimes months. From my own experience, I remember plenty of times going in and asking for whether it be servers or the like, and getting the response, we will add it to the priority queue, and we will get you back a decision once we've figured that out next quarter on whether or not we're going to support you or not. And naturally, everywhere you look, there are stories about, well, yes, we were able to, we were successful. We were able to develop that model. Getting it deployed took half a year, sometimes longer. I'm curious. Naturally, it's always a dangerous topic to ask people about. So, what are the challenges that you faced in your organization? We don't want any of you to get into trouble with your colleagues. So, this could be about other organizations you've seen or prior organizations that you've seen. But I'd love to get your sense as to what has been the biggest problem, and what should people be on the lookout for when they're embarking on this?
So Domino works with customers across a wide variety of industries, and Peter and Ben are customers of Domino. What Domino is seeking to do is really hard. We're trying to build a data science platform that will eliminate a lot of these challenges that we're talking about right now, that will allow data scientists, data engineers, managers of both of those personas, DevOps professionals to work together, and to our goal is to get models into production, as you just articulated. But we're not trying to just solve the model ops problem. We're trying to do that from ideation all the way through that model lifecycle, research and development, validation, and then the model ops at the end, and then monitoring as well. So it's really a very complex, holistic problem. So I feel like as a company, as we're trying to build this platform, we're going through a lot of the same growing pains that our customers are going through, because they're working with IT and data engineers and DevOps to try to solve these problems. One of the main things that I've noticed that is a conflict is the lack of control. This is a conflict for IT, the lack of control by data science, or the feeling on the part of data science that if there is control of my resources, my creativity is stifled. and I can't perform to my best ability because I don't have instant access to tools, I don't have instant access to IDEs, and IT is saying, wait a second, we need some type of governance here. We can't just have the Wild West of desktop data science across all these different terminals all over the place. And I think on the part of data science, what needs to happen is a realization that 1 + 1 can be more than 2. If you do partner with IT and if you allow IT to help with that governance, but at the same time, let it be known what type of flexibility you need, but then be open to some type of governance and control, that you can really be, DevOps problems can go away. You can have instant access to compute, you can have instant access to IDEs, and you can have it in a place where you have a system of record and a history of all your research that's easily shareable and discoverable and allows more collaboration across data scientists. So I think in summary, I think data scientists could do well to embrace some of the governance principles of IT and apply them to their unique realm, because it will improve collaboration, it will improve knowledge management, it will improve the speed of getting models into production. There might be some growing pains at first, but eventually that will happen. And that's one of the problems that we're trying to solve at Domino with software, but it also is definitely a process challenge as well.
Well, you're reminding me of something I heard from the Lean Six Sigma folks, which was on the notions of a value-added complexity and non-value-added complexity. And this is one of those instances where, I mean, for any data scientist, myself as a bad former data scientist included, going and asking me whether or not I would be willing to standardize on one particular tool, I would say, well, of course not. They all have very different strengths and weaknesses. And goodness knows there's all of this exciting development that's happening on the open source side of things. Yeah. If I standardize on it, I'm going to be much less productive. I'm going to be able to build much less effective solutions if I have to do that. So there is this element of there's a value add complexity, but then obviously there's a lot of non-value added complexity when it then comes to, well, I can't replicate anything that my colleague did because we were using different versions of this particular framework, and I can't track down the data that he was using, et cetera, et cetera. So I guess there's this tension of
there is to be able to standardize on an approach to openness. I'm in the camp where I don't think we should restrict data science teams to either Python or R or PyCharm or VS Code or Jupyter or RStudio, whatever it is. Your IDE of choice should be there. Your open source should be an option, but IT can do that. There's a way they can do that and still standardize and and put governance tools in place. But there just needs to be this communication of what is needed and a clear articulation and an acceptance by data science to have some things centralized in, as you said, to add more acceleration to their work. It actually streamlines things and accelerates things faster.
Well, I'm reminded of the communication and language challenges I think, Ben, we've talked about before. So it's there's this element of, well, you need to explain to the data scientist, well, what's in it for you when it comes of why it's actually in your interest to go in and have that governance, this process discipline around this. Much in the same way, it's important to go over to the data on the IT side, go and explain just why it is necessary to have this kind of flexibility. But I want to make sure, Ben, am I summarizing our conversations that we've had before?
Yeah, that's correct. And I had the lovely opportunity at Royal Mail to run the data science and the data engineering teams at the same time. That's once in a lifetime opportunity. I grabbed it, and immediately, I grew up as a data scientist, if you like, from the start of my career. So it was a completely different, and just to add to my learning, that was the time we were trying to stand up a new Hadoop cluster as well. So I jumped into the fire, and you immediately realize why the data engineers work with so much governance and so much structure, because if something goes wrong, they kill the business, whereas if we kill our server, nothing happens, right? So on the data science side, and before I took over both teams, they were in the trenches. We were asking for all this new stuff, and they were saying no, and we can't give you that, etc. But once I was the bridge between the two, I immediately realized, oh wow, they're talking different languages. They just don't understand why. The why is the big learning for me. It's like if you understand why they need that control, then you can explain, okay, that makes sense for this part of the process and not the other part. And over the last 2, 3, 4 years, I've been developing this lean startup approach. And what I realized, having done these 2 roles, is that it's all about uncertainty. The data scientists need the freedom at the start to explore multiple things quickly and in a lean way, so that they can throw it away if it doesn't work, because there's so much uncertainty. And the data engineers are so used to working in the production space where they know everything and they want to control it so that nothing goes wrong. And if something goes wrong, they can fix it quickly. So they're starting from 2 ends of the spectrum. And so what you have to do is bring them together and say, okay, think of uncertainty. At the start, there's so much uncertainty, so we can't have too much governance, can't have too much control. We need the freedom to explore, but then we still can't have the Wild West. It has to be in a controlled environment. So you have a special development environment where you can do that stuff. And then what you have to do is have a process and a set of gates and a set of handshakes, probably, where you progressively harden the solution as you reduce the uncertainty. You know how to do it and you figure it out. And then before you go into deployment, it's fully hardened, it's fully controlled, it's fully governed, so that you can go into production. And that's kind of what we're putting in place at EasyJet, because now that I understand that and I know what needs to be done, I can speak to the data engineers in their own language and say, yeah, I understand that it needs to be there. And we even start with the same templates of everything they need at the end to productionize. But at the start, we just fill the same templates, but just more sparsely, because we don't know everything. And so it's trying to use the same templates, use the same language, use the same tools where possible, but having some flexibility, more flexibility at the start, and then gradually removing that flexibility as we get to more certainty and deploying. That was a really good learning for me.
Well, I mean, there's an element to which, again, the uncertainty is almost inherent in any project. So there's uncertainty around the data that you will need, there's uncertainty around the methods that you'll be using, and there's almost invariably uncertainty around the business use case, because what the business is asked for often either isn't feasible, or they don't actually know what it is that they're looking for, and they'll know it when they see it. So it seems like there's an element whereby just even explaining that level of inherent uncertainty is something that folks need to be comfortable with, versus in a lot of software engineering projects, it's less of a question of whether or not we can build it. It's more of a what should we build?
We don't even know if it can be done at the start. That is the key to a data science project. Otherwise it's not.
And folks, you're all talking about something that I think is really rooted at a deep failure of leadership. I mean, it's a deep failure of business leadership and of technology leadership, and people in roles like the one that I have that cause a lot of this conflict that we're talking about. It's failure on the business side, because if you go one step further with your survey, you're probably going to realize that a lot of the people that responded that ML is the most important thing since sliced bread for the organization, if you ask them, okay, what are you going to do with it? Where are you going to get value from it? The answers get much thinner, and you don't get much in terms of specifics. And I think the other failure, and this really goes to really the hat that I wear, is this notion that all of a sudden you say, now we're going to embed analytics in everything that we do. We hired these 4 guys here that know this thing called data science that nobody else in the company knows, and we're going to put them in a room, and collaboration and alignment will happen magically. And while it doesn't happen like that, just like it doesn't happen, the whole sort of build them, they will come approach to analytics, I think never worked, never paid off. It doesn't work to just place a team of new highly skilled people somewhere and expect that things are just going to sort themselves out. So I think Ben's point was right on the money. You need to create collaboration and alignment. You need to create venues for collaboration. And you need to create common objectives to generate alignment. If you don't have those 2 things, forget about it. Where I do this at Point, right? If you look at my VP of analytics, the 2 closest people that she works with are the VP of product management and my solutions architect. And what she gets from that is, she gets speedy responses to anything where she needs some subject matter expertise from clinicians. It's right there. And anytime she's doing something different that she knows may create problems down the road for deployment, she pulls in the solutions architect early on. And these things get designed. And if we need to do a POC, we do a POC to validate a concept, and it doesn't slow us down. So there are ways for you to create these structures and processes, like Ben was saying, to foster the level of collaboration that makes everybody more successful. It's just that we can't sit back as leaders and expect that, well, people will just sort it out, because they're smart people. They'll figure it out.
You're right to say it's also a triangle, like Kjell was saying. It's not just the data engineers and data scientists. You need to pull the business problem owner as well into that collaboration.
Well, I guess you reminded me of the fact that, well, typically there's nobody who's actually responsible for all of this within an organization. Nobody internalizes this, or if they do internalize it, they internalize it at such a high level. It's at the COO level or the CTO level that they're too far removed from it. I guess I'm curious. We had, unfortunately, Francisco Uribe, who used to head the Google's Perception AI team, and now with his own startup, was saying, well, you could do what the tech giants and startups do, which is to put everybody on the same team, have an integrated engineering and ML research and ML engineering team, and thus try and overcome that lack of incentive alignment. Now, I can imagine this working for startups in the space, and occasionally for the tech giants. But my expectation is that doesn't work for most organizations in the real world. One, because these organizations have been separate, but two, because it might not be as appropriate for some organizations. And I could imagine, Peter, in the research world, I imagining it wouldn't make sense for you to roll up to the same individuals on either the data engineering side, or for you and the data engineering side, or folks on the IT side of things, correct? And I'm assuming that's also the reason why Cesar, you and the VP of Analytics aren't officially on the same team too, right?
No, actually, they are. I now have everything from analytics to the DevOps, SaaS operations. Everything is under me, and it does help with collaboration a little bit. I have to say that.
But you do feel a little bottlenecked by your role, right? You have to sort of coordinate everything for all the teams, and that's something that we're also
more or less, Peter, because if you set up the right processes in place, you don't have to micromanage people. When I'm saying that, you can't be naive to think that things are just going to magically happen. The flip side of that is for you to think that you're dealing with people that aren't capable of sorting stuff out on their own. So there's somewhere in between. And I think when you create these venues for collaboration and you put the processes in place, then you start dealing, as in my case, with the exceptions. These are the things that really don't fit the model. So how are we going to deal with this one? But every time they come up, we also ask ourselves, does the model need to change to accommodate this? Do we see this happening a lot? Do we need to figure out how to not slow this down so that I get pulled in to sort of bring peace? I don't have to do that a whole lot in my team, because that harmonization of life cycles from the research side to the product life cycle side of the house happens a lot by process. So, and to your point, Kjell, I don't believe that, especially in large organizations, you can afford to put everyone in the same team, especially when you're talking about product organizations, and now you're talking about product management and development and other people that do all the operations of your product. It's just totally impossible.
I totally agree.
Yeah, you can have a common coordination body. Now, one thing that requires is that people become comfortable doing something that none of us on the technology side or on the data science side of things are comfortable doing, which is to share half-baked ideas. We wait too long. We wait too long, right? If we work on data science projects so long that we have everything perfectly figured out before we start talking to the technology people, guess what? We're going to be waiting. Right, and the same thing, if I'm introducing a new piece of technology component into the stack and I'm not engaging people early on because I don't have all the answers, I'm slowing things down, right? So we need to have people that trust one another, that are working to coordinate these research activities with technology proof of concept, with infrastructure deployment, with product management roadmaps, and everything is being coordinated in one body, and then dev it up to the different teams to actually do the work.
Well, I feel like you're also touching on something here, which is that deep down inside, at least in the beginning, most of the different stakeholders actually do want to collaborate. They do want to be involved in these things, but we have so many things that actively disincentivize it, so that you end up with individuals who again have to do everything off the side of their desk in order to collaborate. And so when you have structural incentives that at the end of the day penalize people for doing the right thing, it's very difficult to expect them to do the right thing every
and it
time.
never scales as well. Then even if you prove it once or twice, yeah.
I guess I'm glad that we're moving. Sorry, go ahead.
As a quick time check, we got about 5 minutes left, but we're already having a great discussion on, I think, your next section, which was best practices and how to move forward. So we can continue this discussion because we're hitting these points we wanted to hit here, but just wanted to mention about 5 minutes, and then we'll go to the Q&A and get to some of those questions.
Indeed. So I was delighted that we were organically getting to the solution side of things. And I think we've already, to some extent, touched on this. I jokingly refer to successful projects as good heist movies. So if you think of like Ocean's 11 and you think about how you have this range of very unique specialized skills, from the mastermind to the safe cracker to the agility expert, et cetera, you have them collaborating seamlessly to adapt to all of the different twists and turns in the plot line, and all of them have specialized tools. But so you could imagine what Ocean's 11 would look like if everybody was exactly the same. You had just one individual replicated. The only thing that the only tools that they had were chewing gum and sticky tape, and the only way they could communicate with each other are through intake request forms. What is the likelihood of a successful heist? And I think we've surfaced this element of where there's very much of a people aspect of this, whether this be in terms of do we have interpreters who can bridge the gap between the business and data science, or between data science and IT, and between IT and the business? Are there folks there who can do that? Are there leaders there who are willing to take responsibility for that kind of coordination? But then also, do we have processes in place that enable us to do this on an ongoing basis, or do we always have to start from scratch on every new initiative? And naturally, what are the kinds of tools that we have available that can reduce all of these frictions? And so, obviously, there are one of the particular things about the machine learning, AI, data science lifecycle is that you have all of these different roles, and that they often take point in different parts of the lifecycle, which again makes it harder, but again speaks to the importance of this in order to be successful there. But I guess I would love to delve into that. We talked a little bit about on the people side. We've talked a little bit on the process side. I'm curious on the technology side. In the solutions that I see from Domino and others, there often are things that I think look like they would be very helpful for collaboration. So whether that be shareable projects, or model registries, or feature stores, or MLOps capabilities. I guess I'm curious from the technology point of view, are there particular things that you found to be helpful in bridging this divide?
I can speak for, I think there's more flexibility on the technology stack for analytics when it comes to companies that benefit indirectly from it. When it comes to product companies, I don't think we have a whole lot of flexibility. We have to have a standard stack. There's no way around it. One of the things that I mentioned in my opening is that one of the challenges that we've had was having to do code translation, right? Super inefficient. But there's one thing that somebody else mentioned here, which is, well, if analytics writes bad code, we don't need to worry about it, right? Because that's not what's running in production. Well, that's how it used to be. Now, when I start taking people's Python models and exposing them as RESTful API, and we're calling them in real time, we're running data scientist code in the production environment. So that sort of checks the box that from a technology management perspective means that now I need to have all of that source code controlled. I can't have it be all over the place. I need to have all of the handshakes between the technology on the product side and the technology on the analytics side, harmonized so that we don't have performance issues hitting us. I have to add QA to the picture, where data science teams don't normally have to deal with QA. Well, now we have to have QA. because they're running your code in production. So I think that sort of drives the level of requirement that, and I don't think it stifles creativity, but it does add a lot more structure to teams that traditionally have been more sort of free thinking and not have to worry so much about sort of the production side of things.
And it does slow them down, but it's slowing down to go faster, as I always pin it to the data scientists, because my data scientists at Royal Mail, after I learned this thing about data engineers and stuff, we borrowed practices, and the data science team started doing test-driven development. We started writing unit tests so that, the handshake between data science and engineering is not a complete rewrite. It's less of that. And at the start, maybe it's in a notebook because we're just exploring, but as soon as we get some kind of idea going, then it goes into Git. It's following Git flow. We're doing TDD, and we're starting to code more professionally, not as software engineers, but a bit more. So both sides have to give a bit for it to work, so that the handshake is a lot seamless.
I guess I was curious whether or not you can also offload a lot of the support that the things that IT needs to do for the data scientist side of things. So again, I remember my own frustration at just not being able to get access to the infrastructure or tools or data that I needed. And it's not like folks over on the operations side didn't want to support me with that. And it's not like they didn't want me to have access to it. It's just that they didn't have the time to deal with me. I guess I was curious whether or not you're seeing that, and I guess Peter, I'm curious on your side what you've seen folks on the IT side do to make life easier as a data scientist.
Yeah, I think on the research side of things, it's a little bit different from what Caesar and Ben are pointing to, right? The sort of similar environments and stack that you're putting models into production. On the research side, it's a little bit more about the balance between reproducibility and flexibility, right? Because you need the reproducibility to go into, say, whatever I trained on is this set of data, and I need to get this sort of thing moving through the next phase in research, because if it doesn't reproduce, then I can't say it's good science, right? And then flexibility comes in when you're exploring new sort of ideas you want to put into your models or your machine learning pipeline. And one of the ways we have found that kind of helps us is to adopt some of the software development process that helps us in sort of ways. So, what Ben was saying about Git and making sure you tag your commits, we do that, but we do have a more flexible way where we have, we don't refer to the traditional sort of development branch, feature branch, and merge back into master doing deployment. We do it in a way that we are able to track exactly which kind of methods we're implementing this branch, and does it work out? Can we produce good results or not on this sort of set of machine learning tools? And we do it data tracking as well, right? Because every method you're using has to be linked up to some sort of data. So we do snapshotting through Domino, actually, which is a really easy way to help us track the data we're using. So, the best practice there, I don't think it really follows exactly to the dot of software development, but I think there's really some good practice in that we can help us get out some of the research questions we're asking.
I would just add on to that. Peter articulated very well something I had in my mind, which was to be sure in your processes to separate the research phase of data science from the production phase. And they might be done under one platform, but your motions in the research phase are going to be different. It's going to be like you're a life sciences team trying to create a new vaccine. You want to keep track of that old research, make it reproducible so that you don't lose your failures you build upon them. And that's going to be a different motions than when you're in the production pipeline. But Kjell, I do have a couple of good questions from our audience. Should we hit those now?
Absolutely.
Okay, great. One of them is kind of along those lines of what Peter was saying, and which is, I think it's a good question. Who should own governance processes and model ops responsibilities? So, and I would add maybe I'll add myself model monitoring to that too, just if that's not clear, that's under that definition. Any thoughts on that from the panel?
I can go first if you like. And the way I'm setting it up at EasyJet is that, what I always try to do is use the existing processes where they work. It's all about, adding complexity only if it adds value, as Kjell was saying before. So if the IT process already works and they already have stuff going into production as software packages and stuff, they usually use like, the operations team, the monitoring, everything else that works. And for me at that point, if we're going into production from a data science point of view, it has to be that good and that controls they can fit into that process. So you don't necessarily need a new process for a data science model to go into production. There are some potential outliers, but in general, it's at the start where you're doing the exploratory stuff where you need different processes. But when it comes to going into production, you should be able to use the same service design, service transition, all the governance processes, go through all the gates and get it into production and support it. The model monitoring is an interesting one because this is, the data drift in particular is a key thing that usual software packages don't really care. Whereas if you build a model, assuming the data is normally distributed and suddenly the distribution changes, you want to know and you want to take action. So model monitoring is the key different thing that you have to put into place, and you have to have these extra model ops people who are a different breed who don't exist yet most of the time, which we have to put into place to kind of monitor those. And
unique assignment that could come from either side, probably.
Exactly.
Yeah. But we might have time for maybe one more question, then Kjell, maybe you give us some concluding thoughts here as well. I have several questions here that are all along the lines of wording it in different ways. What are the things that IT is doing right now to enable data science? Basically, that's the essence of the question. Kind of what's top of mind for IT in making that transition to supporting data science?
I can take that. I think as part of our transition from our legacy of technology to our new analytics technology stack, what I think IT can do is be a member of that governance layer. And I differentiate. There's different levels of governance, right? There's program level governance, which is really the definition of value. Where's value being defined in the company from an analytics perspective? That needs to happen at a leadership level, and that creates the alignment that all the teams on the technology side, on the product side, analytics side need to sort of march to the same destination. But when it comes to technology, once you figure that out, it puts you in a position to get ahead. The technology teams can't be sitting back and waiting for things to come out of the data science teams in order to start moving, right? We need to get ahead of it and treat data science teams as sort of internal clients, if you will, of the IT team from an infrastructure perspective. And the other thing that we can do is that you don't really need to have draconian measures for data science, right? I really differentiate what I allowed the team to do in the research environment, where they have a ton more freedom. There's even a local admin account that was given to one of the data scientists, so and they can do installation of software, they can play around. As we start getting to prod or close to prod, everything is locked down. Nobody has that type of access. And you can do things in a way that I think is proactive, anticipating what people are going to need if you just take the time to understand what those needs are.
Yeah, that's a great answer. Thanks. Kjell, you mind giving us a summary? Can we use some concluding thoughts here for us?
Oh, absolutely. And I guess the thing that strikes me the most is that at the end of the day, the problems that we're having are actually really good problems to be having. they're an indication of the maturity that we're encountering, and the fact that we are running up against these, but that we're also seeing responses to these is a sign of how these things are becoming more and more important for the organization. So I've often talked about like an artisanal model of data science, whereby, we were thinking of that Leonardo da Vinci style data scientist who could be their own data engineer, who could provision their own infrastructure and understood the AWS console and could also be their own developer. We're now splitting that into a repeatable industrial process and scalable, reusable process. And that's not a fault of data science or of IT. This is a sign that, well, no, we are creating something new here, and it is difficult. It's harder than what we were doing previously in terms of just bridging the IT business gap. This is now the IT business, arguably sometimes data engineering, sometimes data science. It would be a simplification to call it a triangular relationship. It often looks more like a pentagram or a hexagram. But the thing here is that, well, when you do have folks taking leadership here, when you do have folks who are going in and trying to reconfigure their processes around this, and when you do have folks investing in technology to support all of this, then you really do unlock remarkable things. And it's a delight to see it happening. doesn't mean it's easy. And as I think everybody has said here, it certainly doesn't happen by itself. So it's both, what is the term, the best of times and the worst of times, in that the opportunities here, the will is here, the technology is increasingly here, and the data is increasingly here. Again, doesn't make it easy, but you know, what better time to be a practitioner?
Yeah.
AI as the industry analyst.
That's right. Well said, Kjell. Thank you so much. Do you mind going to the last slide so we can show everyone the email addresses? If you like, you can take a snapshot of this, or I'm sure you can find each of us on LinkedIn and connect with us there. Thank you so much, Kjell, Peter, Cesar, and Ben. Thank you for sharing your expertise, your insights on this valuable and interesting topic. And thank you to all of our attendees who joined. We hope you found it beneficial, and we hope you'll join us again for a future webinar. Thank you, everyone.
Thanks for having me.
Thank you.
Cheers.